Okay, there are people who are having questions with the sine and cosine page, 730, 731. Okay, so when you deal with sine and the cosine, you have to remember that if we have this side here, this angle here, angle A, sine, that's your so sine is the opposite over the hypotenuse. So that's the opposite side. So let's call this x for right now. And the hypotenuse, so we'll call this h for hypotenuse. So in this case, the sine of angle A is equal to x over h. And the cosine of angle A would be, we'll call this y. Cosine of angle A remember, cosine is a ka, and A is the adjacent, meaning the one side that shares a side of the angle. This side AC shares a side of the angle BAC. So AC is the adjacent side, and the hypotenuse is still h. So adjacent, in this case that's y over hypotenuse. Okay. Book example, if we're looking at angle A, then its sine is the opposite over the hypotenuse. If we're looking at angle A, its cosine is the adjacent over the hypotenuse. Now the thing to note is that complementary thing. Since this is a right triangle, that means these two angles, A and B, are complementary. Since all three angles of a triangle add to 180 degrees, angle A and angle B have to add to 90 degrees because angle C is 90 degrees. Therefore, angle A and angle B are complementary. So the cosine, the sine of angle A, will be the cosine of angle B. Let's see. If here's angle B, the cosine is, its cosine is the adjacent side. So the cosine of angle B, the complementary angle, let me write that word down, complementary angles, which add to 90 degrees. Okay. Complementary angles add to 90 degrees. The cosine of the complementary angle to angle A, which is angle B, is going to be equal to adjacent over the hypotenuse, x over h. So that the sine of A is the same as the cosine of B. Okay? And similarly, so if your cosine of A is y over h, what do you think the sine of the sine of B is? It's complementary. Yes, here's B. The sine would be the opposite, y over the hypotenuse. Okay. That's a key concept there. If you remember your so, remember what opposite means. It's opposite as you're looking from your angle. And remember what adjacent means. It means it shares a side of the angle. And that idea of complementary depends on where you're looking from, where you're going to get your ratios. Notice that the sine of A is the same as the cosine of B. Cosine of A is the same as the sine of B. They're the same. Okay. Becomes very important, okay, especially when you get to 45-degree angles. So let's say you had, I'm going to freak draw this one, a triangle like this one. We said it's a 5, 12, 13, Pythagorean triple, 5, 12, 13, right triangle. So we asked you, what's the sine of A? And of course, I have to label these things so you can tell where A is. Here's A, here's B, here's C, just like in the other diagram. So here's my angle A. So its sine is its opposite over hypotenuse. And the cosine of A would be its adjacent over hypotenuse. And the cosine of b, well, b is a complementary angle to angle A. We could look at it. B, it's opposite over hypotenuse. Cosine of b is the opposite over the hypotenuse. Cosine of b is the adjacent over the hypotenuse. Cosine is ka is adjacent. Cosine of b is the adjacent over the hypotenuse, which equals the sine of A. You can see that these two are the exact same ratio. Remember, all these trig functions are ratios. They're fractions, which you can convert to decimals. Now let's take an example that you're going to be doing, okay? Finding the missing unknown length, okay? So let's say we have this one here, like number 9. Okay? I'm going to redraw it in my notebook so you can see it. And we have a 37-degree angle at the top, at angle C. Hypotenuse is 15. We don't know that side. And we don't know what AB is. Okay. And we're trying to figure out what X is. Okay. So then we look at this, we carefully say, okay, what is our angle? This is the opposite side and the hypotenuse. So we can say that the sine of C equals x 15ths. And to solve that, multiply by 15. 15 sine, oh, we know what C is, because they told us C is 37. So the sine of 37 is equal to x. Then you grab your calculator. You guys are lucky, we have it all on calculators now. Back in the day, when I had to do this stuff, we had to look up tables in the back of our book and get the closest approximation. 15 times sin 37. Enter. And we see it's 9.027. 9.027. 03 equals x. So the length of that missing side on this, if this was a real life triangle, something big, guy wire, 15 feet, 15 meters, it's an angle of declination of 37 degrees, and we don't know this length, but now we do. We know we tie that guy wire down 9 meters away from, 9.03 meters away from the pole, so to speak. That's what this is all about, okay? Now, the other part is just losing your ratios. Now, look at this one. They don't have the hypotenuse. This side is what? Is it the opposite side of 75? No, it's the adjacent side, okay? So you have the adjacent and the hypotenuse. Or we could say, let me use the complementary angle. Let's see, would that help us? I don't think so. 15 degrees, so we could say the opposite over the hypotenuse. Still got the hypotenuse on the denominator, so you're going to end up dividing by whichever function you choose. Did that make any sense? Probably not, but let's take a quickie look at that. Okay. You got a 75-degree angle here, which means this is 15 degrees. We don't know what the hypotenuse is, but we do know that this is 14. Okay. So if I used, what do I have here? 75, I've got the adjacent and the hypotenuse. I could use cosine 75 equals adjacent over hypotenuse. So we're going to switch these places. So x is 14 divided by the cosine of 75. I could have used it from here. I could have said 15. I could have said complement. So the sine of 15 is 14 over x. I'd still get the same thing. Sine of 15 equals 14 over x. Oh, I'm under 10 minutes. I got to stop. Okay. Sine of 15 is 14 over x. So again, x is 14 divided by the sine of 15. Either one's going to get you the right answer. Pull out the calculator. We said 14 divided by cosine. 14 divided by cosine 75. And you get 54.09, 54.1, or 14 divided by the sine of the complement, 54.1. You can see it works out either way, okay? Whether you use the cosine of the angle or the sine of its complement, you can still get the same thing. Now just remember, when you don't have your hypotenuse, you can end up dividing by whichever trig function you're using. If you don't have your opposite or adjacent side, you can end up multiplying by that. And the last thing is that inverse sine to find the missing angle. So say you had triangle, one side is 8, one side is 18, and we don't know what our angle is. We know that this is a 90 degree. So we could say, here we got opposite over hypotenuse. Which one's opposite over hypotenuse? Opposite over hypotenuse, opposite over hypotenuse. So we can say that the sine of angle A is equal to 8/18. Or we could say the cosine of angle B is equal to 8/18. Okay. And then we just do the inverse. Sine -1 of 8/18 is equal to our angle. That's when you need your calculator. Okay. And if you don't have, well, if you have the sine -1 sign, that's easy. Second, sine -1 of 8/18. I'm not even reducing this fraction to 4/9. And I'll hit enter, and we know that it's a 26.4 degree angle. If you didn't have that sine -1 button, if you just had a sine button, because some calculators don't have the inverse sign. Like if you use your cell phone, you'd have to do the guess and check. You say, okay, well, let me see. Sine of, let me just take a random number, 50. And I get 0.766, but I want to get 4 divided by 9. I want to get close to 0.444. Why did I get 0.444? Because that's our 8/18. 8 divided by 18. That's your 0.444. So you get, okay, sine of something. I don't know, 20. And I get 0.34. So I know I'm a little bit less, so I can guess again. Sine of 25. Enter. 0.42. I'm getting closer. Sine 30. We know what the answer is. We know it's 26, but I'm just going to show you what you do. Oh, it's too far, 0.5. So go sine 26. And you get 0.43, so it's pretty close. Sine 27. 0.45, it's too much, so somewhere between 26 and 27 is our angle. Sine 26.2. 0.44, so it's really close. Sine 26.3. You get the point? And we're even closer. So we know it's around 26.3. Okay. And I could get the exact thing by just using my inverse sine function. 8 divided by 18. And you get 26.4. Okay, that is your answer. So that's what this sine page is all about. Inverse sines, and just remember the so and the ka, opposite over hypotenuse, adjacent over hypotenuse, and then you should be pretty straightforward. And remember that complementary angles are two angles that add to 90 degrees. So if that's a 24 degree angle, what's its complement? It'd be 90 minus 24. This one, they don't tell you what the angles are. Oh, you have to figure out what you're degrees are. So we got from U, it'd be the opposite over hypotenuse. From W, it would be adjacent over hypotenuse. From W, we'd be using the cosine function. For angle U, we'd be using the sine function. Okay? That should be plenty to get you going. And I've talked way too much. All right. Have a good luck with that. See you soon.